The dream of colonizing Mars. It's one of the most powerful and captivating ideas of our time. We're told it's our destiny, the next giant leap for mankind. We see these breathtaking concept images of Martian cities under shimmering domes, and we hear the bold promises of tech billionaires who want to make humanity a multiplanetary species. It's an intoxicating vision, a story of adventure and survival that speaks right to our core. But what if it's also the biggest misdirection in the history of science? What if the most profound discoveries, the answers to our deepest questions about the universe and our place in it, aren't waiting for us on a dusty, lifeless rock right next door? What if they're hiding in the darkest, most distant corners of the cosmos, visible only to our most powerful, unblinking robotic eyes? Today, we're making the case that our obsession with planting flags on the moon and Mars is a profound mistake, and that the true future of human exploration lies not in escaping Earth, but in looking up from it. Let's start with the most common and maybe the most persuasive argument for colonizing Mars. We need a backup planet. The logic is simple and seductive. Earth faces existential threats, climate change, asteroids, supervolcanoes, you name it. So to ensure the survival of our species, we have to set up a self-sustaining outpost somewhere else. Elon Musk, a major proponent of this idea, argues it's a fundamental imperative to safeguard humanity's existence. It sounds noble, it sounds responsible, but when you look past the sales pitch, the backup planet argument just crumbles under the immense weight of reality. The idea that we can just pack our bags and move to Mars is, to put it bluntly, a dangerous fantasy. First, let's talk about what Mars is actually like. It's not a fixer-upper. It's a frozen, irradiated, and practically airless wasteland. The atmosphere is 100 times thinner than Earth's, and is 95% carbon dioxide. You couldn't breathe it. The surface is bombarded with intense solar and cosmic radiation because Mars lacks a global magnetic field to protect it. The average temperature is a brisk negative 55 degrees Celsius, and the soil itself is toxic, laced with perchloric compounds that are harmful to humans. The most desolate, inhospitable places on Earth, the summit of Everest, the deep sea trenches, the heart of Antarctica, are thriving paradises compared to the best real estate on Mars. But what about terraforming is always the next question. Terraforming is the theoretical process of engineering a planet's environment to be more Earth-like. While it makes for great science fiction, with our current or even foreseeable technology, it is wildly impractical. To make Mars livable, you'd need to achieve 3 mind-boggling tasks. 1, build a magnetosphere to shield it from radiation. 2, create an entire atmosphere from scratch. And 3, raise the planet's temperature by dozens of degrees. The scale is staggering. One NASA study concluded that even if you could release all of the carbon dioxide trapped in the Martian surface and polar caps, you wouldn't come close to creating the atmospheric pressure needed for a stable, warm climate. Mars lost its atmosphere billions of years ago due to its low gravity and lack of a magnetic field, and those fundamental problems aren't going away. So the backup planet is a non-starter, but the myth does something more insidious. It gives us an excuse. It suggests that if we fail to take care of our own planet, it's okay because there's another one waiting. It distracts us from solving the very real, very urgent problems right here, like climate change. The idea that we should pour trillions of dollars into a Martian pipe dream rather than investing in the preservation of the only home we have ever known isn't just questionable science, it's a moral failure. But what about the human spirit of exploration? This is the romantic argument. From the first humanoids who walked out of Africa to the sailors who crossed vast oceans, exploration is in our DNA. We have to see what's over the next hill, and sending humans to Mars, the argument goes, is just the next logical step. It's a powerful idea, but it completely misunderstands what exploration means in the 21st century. For millennia, exploration meant you had to physically go somewhere. There was no other way. But technology has changed the very definition of discovery. We no longer need to send a person to find out what a place is like. We can send a proxy, a robot. That is not only cheaper and safer, but in many ways far more effective. Think about what our robotic explorers have already taught us about Mars. For decades, rovers like Spirit, Opportunity, Curiosity, and Perseverance have been our eyes, hands, and geological labs on the red planet. They have operated for years, discovering undeniable evidence that Mars once had liquid water, finding ancient stream beds and lake deposits. Curiosity and Perseverance have detected complex organic molecules, the building blocks of life as we know it, and have identified multiple periods in Mars' past when the environment was potentially habitable. These robots are marvels of engineering. They don't need food, water, or a return ticket. They don't get bored, depressed, or sick from radiation. They can endure conditions that would kill a human astronaut in minutes. And they do it all for a tiny fraction of the cost. NASA's Curiosity rover mission cost about $2.5 billion. Perseverance was around $2.7 billion. Now consider a human mission to Mars. Estimates range from $100 billion to a mind-blowing $1 trillion. Just the Artemis program, designed to return humans to the moon, is projected to cost $93 billion by 2025, with each single launch of its SLS rocket costing an estimated $4.1 billion. For the price of one single risky human mission, we could launch dozens of advanced robotic missions to every corner of the solar system. The scientific return on investment isn't even comparable. Some calculations suggest manned missions are more than 100 times more expensive than robotic ones. Sending humans also introduces a whole host of problems. There's the immense risk to human life. Astronauts would be exposed to dangerous levels of radiation, dramatically increasing their risk to cancer and other health problems. They'd suffer from the debilitating effects of long-term weightlessness and face profound psychological challenges. Then there's planetary contamination. We are walking, talking petri dishes. No matter how well we sterilize a spacecraft, we risk introducing Earth's microbes to Mars, which could destroy our chances of ever knowing if native life ever existed there. The true spirit of exploration isn't about planting flags. It's about the quest for knowledge. And in the modern era, the most powerful tools for that quest are not human footprints, but robotic wheels and telescopic lenses. So if the future isn't about setting up camp on nearby rocks, what is it about? The answer is staring us in the face in the breathtaking images that have redefined our place in the cosmos. The most profound discoveries aren't being made by astronauts. They're being made by our great observatories, our silent, patient eyes in the sky. This is the solution. This is where we should be focusing our energy, our ambition, and our resources. For decades, the Hubble Space Telescope was our window to the heavens, showing us things like the pillars of creation and revealing thousands of galaxies in a patch of sky that looked completely empty. And now we have the James Webb Space Telescope, costing around $10 billion, a figure that, while big, is a fraction of the Artemis program's budget. JWST is engineered to see the universe in infrared light. This allows it to peer through cosmic dust and capture the faint light from the very first stars and galaxies. In just its first few years, JWST has already revolutionized astronomy. It has discovered little red dots that are actually ravenous supermassive black holes from the cosmic dawn, challenging our models of how these giants grow. It has given us the most detailed look ever at the atmospheres of exoplanets, worlds orbiting other stars, searching for the chemical signatures of life. And right here in our solar system, it has given us unprecedented views of the planets, observing volcanic activity on Jupiter's moon in stunning detail. This is the real frontier. Every image from the Webb telescope, every data point from a gravitational wave observatory, every discovery of a new exoplanet opens a door to a new universe of questions. Are we alone? How did the universe begin? What are dark matter and dark energy, the mysterious substances that make up 95% of the cosmos? These are the questions that define our intellectual quest as a species, and they can only be answered by telescopes and advanced instruments, not by sending a handful of people to scrape at the Martian surface. The scientific return from these observatories is staggering and benefits all of humanity. This is where the spirit of exploration leads today, not to a desolate red desert next door, but to the edge of time itself, not to a desperate escape from our problems, but to a deeper understanding of our cosmic context. The dream of walking on Mars is a powerful one, born from a century of science fiction and our innate drive to explore. But we have to be smart enough to distinguish between romantic dreams and rational priorities. Spending hundreds of billions, maybe even trillions of dollars to send a few people on a dangerous, scientifically limited mission to Mars is a spectacular misallocation of resources. The backup planet idea is a technological fantasy that conveniently lets us off the hook for our responsibilities here on Earth. And the argument about the spirit of exploration ignores that our robotic emissaries are already doing a better, cheaper, and safer job. The push for colonization is the biggest misdirection in modern science, driven more by billionaire egos and Cold War era thinking than by sound scientific reasoning. We're told it's our destiny to leave, to conquer new worlds. But perhaps our true destiny lies in our ingenuity, our ability to build tools that extend our senses across unimaginable distances. The most profound discoveries are not waiting for us on Mars. They are waiting in the light from a galaxy 13 billion light years away. They are in the faint wobble of a distant star, hinting at an orbiting world. They are in the gravitational ripples from colliding black holes. Our future isn't about escaping a world we've failed to care for. It's about finally understanding our place within this vast, magnificent, and mysterious cosmos. And for that, we don't need more footprints on another world. We need to look up and see farther. If this got you thinking, be sure to hit the like button and subscribe for more videos breaking down the big ideas in science and space. Let us know in the comments, should we prioritize sending humans to Mars, or should we focus on robotic exploration and deep space telescopes? Thanks for watching, and see you next time.